creating a development workflow for C programming. Now, it's time to start writing some C code. To get started, you need two things, a compiler and an editor. Let's talk about compilers first. A compiler is a special tool that helps you turn your code into a program that a computer can understand and run. There are many different C compilers available in the world, and you can easily get one for free for your Windows, Mac, or Linux computer. So, don't worry, you don't have to pay anything to get started with coding in C. You just need to find a good compiler and editor, and you're ready to go. When you use Linux, you'll often find that it already has a version of the GCC installed. GCC is a powerful tool that has been around for a long time and can do more than just compile C code. It can also compile C++, Objective-C, Go, and many other programming languages. So, if you want to try your hand at coding in any of these languages, GCC is a great option to use. And if you ever need to switch to a different compiler, there are plenty of other choices available too. There's another compiler that's very popular called Clang. It was first made by Apple, but now it's open source, which means lots of people can work together to make it better. Big companies like Google and Microsoft help too. If you use Linux, you can download and install Clang using your favorite package manager. And if you use a Mac, don't worry. Clang and GCC are both great options for you to use too. You can install command line versions of GCC and Clang individually, or you can get a compiler and a special program called an integrated development environment by downloading Apple's Xcode from the Mac App Store. If you use Windows, don't worry. You can also install GCC and Clang, but Microsoft has its own C and C++ compiler that you can use instead. You can get it by downloading the free community edition of Visual Studio. It's important to make sure you have the right kind of license for your situation if you want to use the free community edition of Visual Studio. But if you'd rather use a different editor, don't worry. You can also just install the command line tools instead. Later on, when we do some demos, I'll be using the command line tools for compiling our code. These are just some of the most popular options for compilers, but there are many others out there too. Especially if you're doing special kinds of programming, like programming for tiny computers, there are lots of other options available for you to try out. If you're using a special kind of computer or tiny device, you might find that the people who made it have their own special program for writing and compiling code. But even if they don't, that's okay. Now let's talk about a different kind of program called an editor. An editor is like a special kind of word processor that lets you write code. There are so many different editors out there, but here are some things you might want to look for. Color coding. Good editors can color code your code to make it easier to read and understand. The first thing you want to look for is something called syntax highlighting. This is a fancy way of saying that the editor will color code your code to make it easier to read and understand. This is really helpful when you're looking at a lot of code all at once. Auto-completion. This means the editor will try to finish your code for you, so you don't have to type as much. The second thing you want to look for is something called code completion. This means that the editor will try to guess what you're trying to type and finish it for you. This can save you a lot of time and prevent you from having to look up the exact name of every function you want to use. Easy to use interface. You want an editor that's easy to use and doesn't have too many confusing buttons or menus. Those are just a few things to keep in mind when you're looking for an editor to use for writing C code. But if you're working on really big projects and need even more help, you might want to use something called an IDE. An IDE stands for Integrated Development Environment. It's a fancy way of saying that it's a program that can help you do a lot of different things all in one place. Some popular IDEs include Xcode for Mac, Visual Studio on Windows, and CLion from JetBrains, which works on Windows, Mac, and Linux. IDEs can help you with things like debugging your code, testing it to make sure it works, and even making it run faster. So if you're working on a big project or just want some extra help, an IDE might be the way to go. In the next few demos, I'm going to be using something called Visual Studio. It's a really cool program that can help us write and edit code. The great thing is that it works on lots of different types of computers like Windows, Mac OS, and Linux. Inside Visual Studio, there's something called the activity bar. It's on the left hand side of the screen and has lots of icons you can click on to do different things. One of those icons is called extensions. If you click on it, you can find all kinds of cool things you can add to Visual Studio to make it even better. One of those extensions is called C++. It was created by Microsoft and can help us write code in C++. So that's what we'll be using in the demos. Now that we have Visual Studio set up, we need to add something called an extension to it. This will help us write code in C++ even better. To find the extension, you just need to type the letter C in the search box at the top of the screen, and it should show up first in the list. Once we add the extension, Visual Studio will be able to do even more cool things for us, like making sure our spelling and grammar is correct and highlighting different parts of our code so it's easier to read. Now we're all set. We can start writing our very first C++ program. It's going to be so exciting. But first, let me tell you a little bit about something called compilation. This is how we turn the code we write into a program that the computer can understand and run. Compiling can be a little tricky, but don't worry, we'll go through it step by step together. Are you ready to start writing some code? Understanding the compilation process in C. Understanding how C programs are compiled can help you see how small code files turn into large applications. In C, there are two main file types, header files and source code files. Header files, which usually have an H extension, contain declarations of functions, variables, and other data types. These files are included at the top of source code files and tell the compiler what the program will use. The source code files contain the actual code of the program and usually have a C extension. Source code files, on the other hand, have a C extension and contain the actual code that defines the functions declared in the header files. Let me show you an example. Here's a file called products. See, that includes the products H header file we just looked at. In this file, we define the two functions declared in the header file, display product and get price. As you can see, the functions contain the actual code that performs the operations specified in the function names. Header files are like a menu at a restaurant. They list all the different dishes that are available along with their names and ingredients. Just like you wouldn't find the recipe for a dish on the menu, header files only contain declarations of functions, not their actual code. This helps keep things organized and allows different parts of a program to share information about functions without having to write the same declaration over and over again. On the other hand, source code files are like the kitchen where the food is actually made. They contain the actual code for the functions that are declared in the header files. When you want to use a function in your program, you include the appropriate header file, which tells the compiler what the function looks like, its name, return type, and parameters. The compiler then looks for the function's definition in the source code files and links everything together to create the final executable program. So, header files and source code files work together to make sure that the right functions are available in the right places in a program. Now, to compile these files into an executable program, we need to use a compiler. The compiler takes the source code files and compiles them into object files, which are machine-readable code that the computer can execute. Then, the linker takes the object files and links them together into a single executable file. This executable file is what you can run on your computer to execute the program. In this example, if I want to use the display product function inside a file called inventory, see, I have to add an #include directive that essentially imports the function declarations from the products H file. With that in place, I can now call this function inside this file. This lets programmers declare functions in one place and use those declarations everywhere they need to call the function simply by importing the declaration. The executable is the file that you double-click to launch the program. The compiler is responsible for translating your C code into machine code that the computer can understand and execute. The linker is responsible for combining all the object files into a single executable file. During the compilation process, the compiler checks for syntax errors and other issues in your code. If it finds any errors, it will produce error messages that you can use to debug your code. Once the compiler has finished compiling your code, you can run the executable to see if it works as expected. In the upcoming demos, we'll be using Visual Studio Code to compile and run our C code. But it's important to note that there are many other compilers and build systems out there, and you may need to use a different one depending on your specific needs and requirements. This is the general process, and it's helpful to understand at a high level. However, it's essential to note that compilers have many options available to customize the compilation process. Additionally, there are many large C programs in the world, and various build systems are available to automate the building of these programs. These build systems help teams manage and automate the building process, making it easier to work on and distribute large C programs. One of the oldest and most popular programs used for build automation with C is called Make. It's been a favorite among C developers for decades. With Make, you can create a Make file that contains all the details about each step in your build process. This helps teams automate the building of their programs. Let's wrap it up for now. We'll bring you more informative content in our next video. If you have any questions, please leave them in the comments below, and don't forget to subscribe and share this video. Thank you for watching.